Hello everybody, my name is Luca Comanducci and I'm a PhD student from the Politecnico di Milano. I'm very glad to be giving this presentation for the 27th edition of FRUCT and the International Workshop on the Internet of Sounds. The paper that I'm going to present is called An Adaptive Metronome Technique for Mitigating the Impact of Latency in Networking Music Performances and was written by Riccardo Battello, myself, Fabio Antonacci and Augusto Sarti from the Politecnico di Milano, and Stefano Delle, Monache, Giovanni Cospito, Enrico Pietrocola, and Filippo Berbenni from the Conservatorio di Milano. This work situates itself in the context of networking music performance research, which is an interdisciplinary field that deals with the problem of conducting real-time music interaction over a computer network, thus making musicians play together when geographically displaced and interacting over a network. This work is also part of the Intermusic project, which is a interdisciplinary project made as a collaboration between conservatories and universities that aims at the development of networking music performances solutions for didactic scenarios. Specifically, this means to concentrate on two different types of courses, such as music theory and teaching courses, where interaction is usually one-to-many or one-to-one. And there are no strict latency or synchronicity requirements. And another type of courses, which are the one considered in this work, which is specifically music practice and rehearsals, and specifically chamber music. In these courses, we have musicians that have to practice and rehearse together over a network, and thus there are higher synchronicity requirements. In order to guarantee the synchronicity between the musicians and to keep low the temporal separation between them, we must take into account the latency of the system. In a networking music performance, this latency is due to two main factors: processing latency and network latency. While processing latency is due to the hardware used to acquire the audio and is negligible, the network latency is unavoidable and is due to the time that packets need to pass from one endpoint to the other one of the connection. And this is very important since the sensibility of the human hearing to the temporal separation is in order of 10 to 20 milliseconds. And high latency values can lead to low synchronicity between the musicians and can slow or accelerate the tempo of their performance. So, a great amount of NMP research is aimed at dealing with latency. And this can be done with several paradigms. One of these is to minimize the latency, which can be done through low latency transmission softwares such as LoLa and UltraGrid that work really well. However, they have hardware requirements which may not be available to all people, and especially to students. Other approaches do not try to minimize the latency, but to cope with it. For example, we have the master-slave approach, of which I'm going to talk later in the presentation, the delayed feedback approach, or metronome-based techniques, where a metronome is a device that produces a regular click sound and is used by the musicians to rehearse and be able to keep a steady tempo. In this work, we propose a latency coping technique that is based on the combination of the adaptive metronomes and the master-slave strategy. While this does not pretend to be a ready-to-use method, it can be considered as a first exploration of the use of adaptive metronomes in this context. And specifically, the idea behind the master-slave coping strategy is that one musician does not care about the audio from the other musician and is called the leader, while the other musician, the follower, strictly follows the tempo and the audio of the other musician. So the idea here is to use an adaptive metronome to track the tempo on the follower of the leader and to send this signal to the follower in order to enhance its capacity in following the leader and thus keeping a stable tempo. The technique that enables us to track the tempo of the follower musician is called beat tracking, where beat tracking is a method based on a several set of algorithms that through the detection of the audio onsets, the beginning of the notes, and using optimization techniques, is able to select the onsets corresponding to musical beats and use these in order to retrieve the tempo information in bit per minute corresponding to the considered audio signal. And this can either be implemented on all the duration of the audio signal that we have or on a small slice of it, as we do in this work. As it is shown in the schematics of the metronome method, both musicians receive the audio feedback relative to the other musician, delayed by the inherent network latency. However, the audio received by the follower is also processed by the bit tracking method and is used to regulate the tempo of a metronome signal that you can hear through headphones. The adaptive metronome functions by modifying the tempo of a metronome depending on the difference between the tempo detected in a selected window and the target one. The beat tracker detects a new tempo after beta successive beats. If the difference between the target tempo and the desired one is lower than a percentage controlled by the epsilon parameter, then the metronome is updated with the new tempo. Otherwise, the previously detected one is used. This choice is due to the fact that abrupt changes in tempo would be not useful for the musicians and would worsen their performance. So through the epsilon parameter, we control how much is the difference in tempo that the musicians can find useful, while the beta parameter determines the width of the window, which means how accurate and how fast is the beat tracking. In order to validate the effectiveness of the adaptive metronome technique, we performed a few experiments in the Conservatory of Milan. Specifically, we considered four couples consisting of musicians, consisting of duets, such as oboe, guitar, and saxophone, and we made them play through connected in two different rooms via LoLa and using a network emulator in order to emulate the latency. We considered two different latency conditions, one with a low latency of 25 milliseconds one way, and one with a high latency of 16 milliseconds one way. And with both latency, we considered both with and without the use of the adaptive metronome. We first analyzed the results by means of objective analysis that consider numerical attributes related to the recorded audio tracks corresponding to the various performances of the musicians. We first take into account the tempo trend, which measures how well the musicians are able to keep the tempo during the performance. Here we report the example where we consider a 25 millisecond latency one way and the duet of guitars. Here the tempo of reference, the desired tempo, is that of 104 beats per minute. And on the left we have the condition without the metronome, and on the right the condition with the metronome. As it is possible to see, when the metronome is not used, there is a steady decrease in tempo, reaching almost 90 BPM from the 100 BPM of start. While on the right, even though there is an acceleration, this is small, and also the musicians tend to go nearer to the desired tempo. We also report some results related to the asymmetry of the musicians, which means how well they are synchronized. And it is possible to see, while with the low latency condition, the metronome does not seem to help, since probably the latency is so small that they are able to compensate it themselves. While we consider high levels of latency, the 50 milliseconds, the metronome seems to provide some help to the musician. We also gave the musicians a little questionnaire in order to assess how was their performance and their experience. And while limiting the number of participants, we can define that the metronome seems to help them, but most importantly, this seems not to be affected by the use of a metronome. It does not make them perform worse, so it's not perceived as strange. To conclude, this work is a first exploration of the use of adaptive metronomes in the context of networked music performance in order to compensate the latency. While results are only preliminary, They show that this can be a viable solution to the problem of latency and motivates us to further developments, such as the development of some sort of virtual conductor where the tempo of each musician is tracked simultaneously and is used to provide to each of them different tempo informations in order to, again, compensate the latency as much as possible. So, thanks for your attention. And if you have any questions, I'll be glad to answer them in the question and answers Zoom session.